In this lesson, you'll learn how to read trends, compare data, understand rates of change, and solve real SAT line graph questions with confidence, all in just 20 minutes. A line graph is one of the most important visuals you'll encounter in SAT data analysis, because it clearly shows how a value changes over time. Each point on the graph represents a specific measurement, and when those points are connected, they reveal a pattern that helps you understand the overall behavior of the data. What makes line graphs powerful is the combination of detail and big-picture insight. You can see the exact values at each moment, but you can also see whether the trend is moving upward, downward, or staying relatively stable. This dual perspective is essential when analyzing real-world situations. On the SAT, line graphs are used to test whether you can describe trends, compare different time periods, judge how fast something is changing, or identify key moments such as peaks and turning points. By mastering how to interpret these features, you'll be much better equipped to solve data analysis questions quickly and accurately. This foundation will support everything we learn in the rest of the lesson. When you read a line graph, it's important to begin by understanding what story the graph is trying to tell. A line graph is really about movement over time, so the first step is to look at the overall direction of the data. Start by comparing the point at the beginning with the point at the end. This simple comparison gives you a sense of whether the data is generally going up, generally going down, or staying almost flat with only small changes. It's easy to get distracted by small bumps or dips along the way. But for most SAT questions, those tiny changes don't change the main message. What matters is the big picture, the broad, overall trend. Once you see that big picture, you can begin to interpret the graph more deeply. You can ask, how fast is the change happening? Is the increase steady or does it accelerate? Is there a moment where the trend shifts direction? By training yourself to identify the trend first, you'll be able to read line graphs more confidently and avoid common SAT traps that confuse many students. One of the core skills in line graph interpretation is recognizing increases and decreases. An increase occurs when the graph moves upward as time goes forward. This upward movement represents a positive slope, meaning the value is rising. Even if there are small bumps or small fluctuations, start by looking at the big picture. Does the line generally climb from left to right? A decrease happens when the graph moves downward over time. A downward movement means a negative slope, showing that the value is falling. Pay attention to whether this decline is steady or only temporary, because SAT questions often depend on these differences. On the SAT, you may see questions like, during which interval does the greatest increase occur? Or, in which period does the value decrease? The most reliable way to answer is to compare the slopes of each segment rather than just comparing the beginning and end values. Mastering this skill will make many data analysis questions much more manageable. On this slide, let's look at how to compare local changes with the overall trend on a graph. The most important idea is the overall trend, the general direction of the data from the start to the end. When you look at the full graph, ask yourself a simple question. Is the data increasing, decreasing, or staying roughly the same over time? That's the big picture. Now, graphs also include local changes, small ups and downs that happen along the way. These short-term movements can appear as local dips or temporary spikes. But remember, a local change does not decide the overall trend. It only shows what happens in a short interval, not the long-term direction. This distinction is extremely important on the SAT. Many questions test whether you can focus on the overall trend without being distracted by small, temporary dips. So when you analyze a graph, don't let a small drop fool you. Follow the general direction from start to end. That's where the real story of the data is. Here's how to compare slopes across different intervals of a line graph. An interval shows how much the line rises or falls during a specific segment of time. Let's start with interval A here. The graph shows a small upward movement. Because the change is gradual, we call this a gentle slope. Nothing dramatic is happening, and the rise is slow. Now look at interval B. This section has the sharpest upward movement in the entire graph. The value increases quickly in a short period of time, so this interval represents the steepest slope, meaning the greatest increase. Finally, interval C shows a rise that is greater than A but less dramatic than B. This gives us a moderate slope. It's noticeable, but not extreme. On the SAT, remember this rule. To find where the graph increases the most, don't compare the final heights, compare the slopes within each interval. The interval with the steepest slope shows the largest increase. Let's compare two lines in a line graph, line A in blue, and line B in red. When you compare two lines, the most important idea is the slope. A steeper slope means a faster rate of increase, while a gentler slope means a slower rate of change. In this example, line A starts lower than line B, but it rises much faster. That's why the two lines intersect around the middle of the graph. Before the intersection, line B has the higher value. But after the intersection, line A grows at a faster rate and eventually becomes higher. This highlights a key SAT idea. A line that ends higher is not always the one that grew faster. What really matters is how quickly the line rises within each interval. So when you're comparing two lines, always focus on the slopes, not just the final numbers, and pay attention to where the lines cross. SAT questions often ask, which line increased more rapidly between years 1 and 3? And the answer will always depend on the steepness of the slope in that interval. Now let's apply everything we've learned to a real SAT-style comparison. Here, we have the sales of product A and product B over 4 years. Both lines move upward, which means both products are increasing in sales. But the key question is not simply which one is higher, it's how their rates of change differ over time. Let's start with product A. Product A shows a very steady pattern. From year 1 to year 2, from year 2 to year 3, and again to year 4, the line rises at almost the same gentle, consistent pace. This is what we call uniform growth, predictable and smooth. Now look at product B. Product B starts lower than product A, but its rate of growth gradually increases. The rise from year 1 to year 2 is modest, but from year 2 to year 3, the growth becomes stronger, and from year 3 to year 4, it accelerates even more. This kind of pattern is called increasing growth. The slope becomes steeper as time goes on. In many SAT questions, you'll be asked something like, which product grew faster between year 2 and year 3? Or, during which interval does product B show the greatest increase? To answer these, don't look at final values. Instead, focus on the slopes, how steep each segment is within each interval. Even though product A ends at a higher value, that doesn't automatically mean it grew faster. Product B might have a steeper slope in certain intervals, especially in the later years. That is exactly the type of subtle reasoning the SAT wants you to demonstrate. So whenever you compare two real data lines, remember this. Look at the shape, look at the intervals, and look at the rate of change. Heights can be misleading, slopes reveal the truth. Before we move into the practice section, let's take a moment to review what you've learned so far. You now understand how to identify the overall trend in a line graph by looking at the direction from start to end. You've also learned how to recognize increases and decreases, and how to ignore small fluctuations so you can focus on the big picture. We discussed the difference between local changes and the overall trend, which is a key skill on the SAT, since small dips can't distract you from the true direction of the graph. You also learned how to compare slopes in different intervals, distinguishing gentle, moderate, and steep changes, and how slope, not height, determines the rate of increase. And finally, you learned how to compare two lines within the same graph, including how to recognize which line is rising faster and when one line overtakes the other. Now that you understand all the core ideas, it's time to apply them. In the next section, you'll work through 3 SAT-style practice questions: a beginner question, an intermediate question, and an advanced question. For each problem, you'll have quiet time to solve it on your own, followed by a clear, step-by-step explanation. Let's begin the practice section. Here is your beginner practice question. Look at the line graph on the right and compare how much the value changes between each pair of years. Your task is to find the interval with the greatest increase. You'll have 60 seconds to solve it. Now let's walk through the answer to this beginner practice question in detail. The line graph shows the sales of product A across 4 years. The values are 100 in year 1, 120 in year 2, 135 in year 3, and 150 in year 4. To determine where the greatest increase occurs, we compare the change between each pair of years. From year 1 to year 2, the value rises from 100 to 120. That's an increase of 20. From year 2 to year 3, the sales go from 120 to 135, which is an increase of 15. And from year 3 to year 4, the value increases from 135 to 150, again an increase of 15. When we compare these increases, 20, 15, and 15, the largest change is 20, and it appears only once. It happens between year 1 and year 2, which makes it the correct answer. On SAT data analysis questions, always remember, don't focus only on the final heights of the points. What truly matters is how quickly the value changes, or in other words, the slope. Understanding these differences will help you make accurate comparisons and avoid common mistakes on the test. This one requires a deeper look at the graph, not just reading values, but interpreting patterns and comparing changes carefully. Take a moment to examine the chart, then pause the video and try the problem yourself. Let's check the intermediate question together. The graph shows the sales of product B over 4 years, and we want to find the year with the greatest increase compared with the previous year. Read the values first. Year 1 is 100, year 2 is 115, year 3 is 130, and year 4 is 140. Now calculate the year-to-year increases. From year 1 to year 2, the increase is 15. From year 2 to year 3, the increase is also 15. From year 3 to year 4, the increase is 10. The greatest increase is 15, which occurs twice. However, the first time that greatest value appears is between year 1 and year 2. Therefore, the correct answer is A, year 1 right pointing arrow year 2. On SAT data analysis questions, always compare differences and check whether the question asks for the greatest, the least, or the first time a value appears. Here is your advanced practice question. You're looking at the revenue of Company A and Company B over 2 years. Your task is to decide which company shows greater overall growth from the first quarter to the last. Take your time. You will have 120 seconds of quiet time to solve it. Here's why the correct answer is Company B. Company A begins at $100,000 and ends at $180,000. That is an increase of $80,000. Company B begins lower, at $80,000, but ends at $175,000. That's an increase of $95,000, already larger than Company A's increase. Now let's compare percentage growth. For Company A, 80 divided by 100 is exactly 80%. For Company B, 95 divided by 80 is about 118.7%. So Company B grows much faster relative to its starting point. We can also look at the average slope across the 7-time intervals. Company A increases by about 11.4 per quarter, while Company B increases by about 13.6 per quarter. This means Company B's line is steeper overall. On the SAT, when a question asks, which grew faster overall, we compare changes from the starting value, both absolute and percent, not just the final height. And by all measures, Company B grew faster. Here is the final summary of everything we learned about reading line graphs. A line graph is one of the most important visuals on the SAT because it shows how values change over time. To understand any graph, begin with the overall trend. Look from the starting point to the ending point and decide whether the data is rising, falling, or staying stable. Next, focus on slopes. A steeper slope means a faster rate of change, while a gentler slope shows slower growth. Even if two lines end at similar values, the line with the steeper slope grew faster along the way. Be especially careful with the y-axis scale. The SAT loves to include graphs where the y-axis doesn't start at 0 or uses a very narrow range. These graphs can make small changes look dramatic. Always check the scale before drawing any conclusions. The visual impression can be misleading. We also talked about local changes. Small bumps or dips can appear, but they don't define the overall trend. The SAT often asks you to distinguish overall trend from local behavior, so stay focused on the big picture. Finally, when comparing two lines, look for which line rises faster, where they intersect, and how steep each interval is. Remember, the SAT cares about rate of change, not just the final height of the graph. With these strategies, you'll be ready to analyze any line graph confidently and avoid common SAT traps.